Hello friends, and welcome once again to this video. Perhaps this is the last video in this research paper, and today we shall study about the Anova test. As you can see, Anova test is a non-parametric test, and it is a parametric test. So when you have to find the mean comparison of more than two groups of variables, then we do the Anova test. So how do we go about finding out the Anova value is basically we need to find sum of squares between and within groups divided by the respective degrees of freedom. So that's how you find the Anova test, basically to find out whether it is statistically significant. Now the formula is F is equal to mean squares between groups divided by mean squares within groups. The degree of freedom for mean squares between groups is k minus 1. K is equal to number of groups, whereas mean squares within groups, the degree of freedom is n minus k. That is, n is total number of people and k is number of groups. Now let us straight away take an example. Here is an example of 3 groups of 5 subjects each. They are selected randomly to determine credibility of a newspaper ad for a laundry detergent. The groups are exposed to varied degree of complexity of ad, and the subjects are asked to rate on a scale of 1 to 10. So these are the groups. The first group is given easy ad, second group is given medium ad, and third group is given difficult ad. Okay, so we find out the Anova value and see whether it is statistically significant. So before going ahead, we have some more things to do. That is, we need to find out total sum of squares, within sum of squares, and between sum of squares. Now, what is the formula for total sum of squares? Sigma x square minus sigma x whole square divided by n. And for within sum of squares, the formula is sigma x square minus sigma x whole square divided by nk. Now, what is nk? Nk is sample size of each group. That's what nk is, sample size of each group. That is, if there are 5 people in a group, that is 5. Second group 5, third group 5. So that is the value of nk. Now let's go to the example that we have taken. The easy group is here, the medium group is here, difficult group is here. Now what I first do is I square up. If this is x, I do x squared. So this is what I have done here. For this group also I have done x squared here, and for this group also I have done x squared. If you can see, 6 squares are 36, 7 squares are 49, 10 squares are 100. So this is how I have done the squaring. Then you total it. There is slight mistake here. This is not 15. This is supposed to be 16. If you can see, 2, 3, 7, 11, 5. So this is supposed to be 16. I made a mistake here. This is 16. This is of course 62, 29, 177, 38, and 298. So sigma x is 16 plus 29 plus 38, that is 83. So what you are counting is this value, that is 16, 29, and 38. And sigma x whole square is 62, 177, 298. That's what you are counting here. 62, 177, 298. So that is 537. This is 83. So total sum of squares, I've given you the formula already. Sigma x square minus sigma x whole square divided by n. So sigma x whole square is 537 minus sigma x whole square. If you can see, this is the sigma x whole square, 83 whole square divided by n. That is total number of people. That means in first group there are 5, second group 5, third group 5. So it becomes 15. So the value is 537 minus 6889. That is 83 whole square divided by 15. So the final value is 77.8. So that is total sum of squares. We also need other within sum of squares and between sum of squares. So within sum of squares, The formula is sigma x square minus sigma x whole square minus nk. So how do you do that? Nk. So each group separately you need to do. So 537 minus 16 square divided by 5 minus 29 square divided by 5 minus 38 square divided by 5. So this is the total mean, the total value of each group, that is 16, 29 and 38. Let me go back and tell you this. So this is a mistake. I said 16, 29 and 38. This is what you have done there. So and the value you get is 537 minus 51.2, that is this value, minus 168.2, that is this value, minus 288.8, that is this value. So what you get is 28.8. Now we got total sum of squares. Within sum of squares, you need to get between sum of squares. How do you get between sum of squares? It's very simple. Total sum of square minus within sum of squares, that's the value of between sum of squares. So between sum of squares is 77.8, as you can see here, and then within sum of squares you got the value here 28.8, so that is 49. Okay, now you make a chart like this, but you write source of variation, degree of freedom, sum of squares, mean squares, and the f value. This is between groups and this is within groups, and of course this is the total. Now degree of freedom for between groups is 2. Why 2? Here is the formula between groups. As I have told you already, degree of freedom is k minus 1. K is total number of groups minus 1. That is 3 minus 1. 3 groups are there. So value is 2. Within groups is 12. Why? Because the formula is n minus k. So n is total number of subjects, total number of people, minus k. That is groups. So 15 minus 3 is 12, is the value of within groups. Now let us come to sum of squares. Between groups we have got 49 and 28.8. Already we have got this value. Let me go back and tell you this. So here it is. Between groups is 49 and within groups is 28.8. That's what I have written here, 49 and 28.8. Now mean squares, how do you get the mean squares? Simple. You divide sum of squares by degree of freedom. That's when you get the mean squares. So 49 divided by 2, 24.5. 28.8 divided by 12, you get 2.4. When you do this, I get f value. How did I get f value? It is once again simple. Mean squares, which I got just now. This is the formula, final formula to get f value. That is mean squares between groups and mean squares divided by mean squares within groups. That is 24.5 divided by 2.4. So that's how I get the value 10.2. Let me go back and tell you. So you divide this value by this value. That's when you get the f value. So that's what you have got here, 10.2. Now, if the value, that is f value, Anova value that you got, is greater than the table value, okay, then there is significant difference. That's a significant difference. But if what the results that you've got are not greater than the table value, then there is no statistical. Statistically, it's not significant. That's how you have to. So that it is not statistically significant. Now the table value, that is table value, you have to take the degree of freedom, that is total degree of freedom you have to take for 14. So go and check the data for F data, that is at the end of the research book. So go and check that for 14. You get table data this 3.88. So this is the table data. So whatever data you have got, that is F value 10.2 is what you have got. So this is greater than 3.88. So the Anova test will tell you that the Anova test is statistically significant. Which means you will go back to the means and see which has got higher mean, which has got lower mean. Accordingly, they value or they let's say judge that advertisement. So the test is statistically significant. So what I'll do is, maybe I'll send you one or two tests to work out at home. You can work out and send it to me so that you also learn how to do ANOVA test. Thank you.